All right, today we're going to take a look at Unit 11, Lesson 4. This is where we're going to use our system of equations involving word problems. So up to this point, there are three different ways that we've been able to solve systems. The first one is by graphing. The second one is by substitution. And our last one is by elimination. Now, when we are working with our word problems, you will probably most likely use either substitution or elimination. These seem to work a little bit more efficiently than it would be to graph the equations. So let's take a look at our first example. It says that during a football game, the parents of the football players sell pretzels and popcorn to raise money for their new uniforms. They charge $2.50 for a bag of popcorn and $2 for pretzels. The parents collect a total of $336 in sales during the game. They sell twice as many bags of popcorn as they do pretzels. How many bags of popcorn do they sell, and how many pretzels do they sell? Now, to start these problems, since we have our system that we're going to set up, we need to make sure that we properly label both of our variables. So x, I'm going to say, is equal to my pretzels, and y is going to be equal to the popcorn. This will make things a little bit easier when it comes to the end of the problem and actually explaining what you are working with here. So if we go back to the information that's given, it says that it's $2 for each pretzel and $2.50 for each bag of popcorn, and they sold a total of $336. So this is our first equation. We just pulled the information from our problem. Now the next part is a little bit trickier. It says that they sell twice as many bags of popcorn as they do pretzels. This is where our second equation is going to come from. So what it says is our popcorn is equal to twice as many pretzels. Now, if we take a look, we now have our system of equations. In order to solve for x and y, the easiest option here would be to use substitution because we have this y by itself on one side. So what that means is we're going to substitute in 2x wherever we see y. So when we move on to that setup, I have 2x plus 250 times 2x equals 336. Now 250 times 2 is going to give me 5, so I have 2x plus 5x equals 336. Move my work up here. 2x plus 5x is 7x equals 336. Divide both sides by 7, and I get x is equal to 48. So I have 48 pretzels that were sold. And now, oops, I'm off the paper here. And now to find our number of bags of popcorn sold, we can plug this x right back in to the second equation. So it would be y equals 2 times 48, which gives me 96. So I had 96 bags of popcorn. So these are our answers for this section. They wanted to know how many of each were sold. So again, you need to make sure that you label your variables, meaning what is what, and then you need to make sure that you solve for both the pretzels and the popcorn. Just like we did in all of our other sections, you're solving for x and y. All right, moving on to part B here. It says that a rectangle has a perimeter of 58 inches, and then it says the length is 1 more than 3 times the width. Well, if you recall, perimeter is the space around. So if I'm looking at my rectangle here, we're looking at the outside. So remember that equation is going to be 2L plus 2W equals your perimeter. Now, for each of these, we're going to find the length and the width. So when we set up our variables, I'm just going to say that L is equal to my length, and W is equal to the width. So it tells me right here that the perimeter is 58. So my first equation is going to be 2L plus 2W equals 58. Then we need to find that second equation. That's going to come from this information here. It says the length, so L is, remember that is means equal to, 1 more than, so in this case this is going to be addition, 3 times the width. So this is going to be 1 more than 3W. So now I have my two equations, and I need to solve for the length and the width. That's what we're going to do in the second part here. Again, the best option for us would be to use substitution because we have the length already by itself. So we're just going to drop that in to our other equation. We're going to substitute it in wherever we see L. So when I substitute, I have 2 times 3W plus 1 plus 2W equals 58. You need to make sure that you distribute that 2 to each term. So I have 6W plus 2 plus 2W equals 58. Combine like terms, I have that 6W and 2W, so 8W plus 2 equals 58. Subtract 2 from both sides, and I have 8W equals 56. Again, I'm going to move my work back up to the top, so I have 8W equals 56. Now I want to get that W by itself, so we know we need to divide both sides by 8. So I get that W is equal to 7. So my width is equal to 7 inches. You need to make sure that you include the unit if there's one given to you. Now we need to find the length. We can find the length by plugging it back in to our second equation. So I have L is equal to 3 times 7 plus 1. Well, 3 times 7 is 21, plus 1 is 22. So my length is going to be 22 inches. So this is my answer here. Again, we can check this back in by adding up all the sides. So 22 plus 22 plus 7 plus 7 gives me 58. So for both of these examples, if you guys want to scroll back up next to example 1, why don't we write that we use substitution for both of these problems, for part A and part B. Now, we're going to skip the U-tries for now. You guys are going to try those tomorrow in the start of class. You can flip to the next page here. We're going to take a look at our second example. Now, taking a look at example 2, it says at a garden shop, a customer pays $48 for 5 geraniums and 4 lilies, and then another customer pays $58 for 4 geraniums and 6 lilies. So again, we need to set up our system of linear equations. The first thing I'm going to do is I'm going to label my variables. I'm just going to say X is the geraniums and Y is going to be the lilies. Again, you guys can pick any letters that you want as long as they are different because we're talking about 2 separate things here. So now we need to set up our system. So the first person spent a total of $48 and they bought 5 geraniums and 4 lilies. So we're trying to find the cost of each flower. Now, the second customer spent a total of $58 and they bought 4 geraniums and 6 lilies. So this is our system here. If you recall, we are in standard form for both these equations, so solving using elimination will probably be the best option here. So we need to find something that we want to eliminate. Looking at mine, I think I am going to eliminate my y's here, so that I want both of these terms to be 12. Well, positive 12 and negative 12. So that means I'm going to multiply the top one by negative 3 and the bottom by 2. Now you need to make sure that you remember that you need to distribute this negative 3 to each term. So I have negative 15x minus 12y equals negative 144. My second equation, I'll have 8x plus 12y equals 116. So now remember, when you're using elimination, we want something to cancel out. So my y's cancel out. So negative 15 plus 8 is a negative 7x. And that is equal to negative 144 plus 116 is a negative 28. Divide both sides by negative 7. And I get x is equal to a positive 4. So the geraniums are $4 for each geranium. Now we need to find the cost of our lily. So again, we can just take this value for x and plug it back into one of the original equations that we set up. So if I plug it back into just my first one here, I would have 5 times 4 minus 4y equals 48. 5 times 4 is 20. So to get rid of it, I have to subtract 20 from both sides. So I have negative 4y. Oops, sorry, that should be positive 4. Equals 28. Divide both sides by 4 here. And I have that my y is equal to 7. So it's going to be $7 for each lily. Again, you can plug these back into the original and make sure that it works out. We have 5 times 4 is 20, plus 4 times 7 is 28, so that gives me 48. So that works there. You need to make sure that they check in both equations. In our next one, I have 4 times 4 would be 16, plus 42, again gives me 58. So these are the correct solutions. So it's going to be $4 for each geranium and $7 for each lily. Make sure that we set up your systems correctly. You can just pull that information directly from each of these problems and make sure that they check. You should always be checking your solution, making sure that your answer does in fact make sense. All right, let's move on to letter B. We have that Lisa and Michaela are selling fruit for a school fundraiser. Customers can buy small boxes of oranges or large boxes of oranges. Lisa sold 10 small boxes of oranges and 1 large box of oranges for a total of $51. Michaela sold 14 small boxes and 10 large boxes for $166. What is the cost of 1 small box of oranges and what is the cost of 1 large box of oranges? So again, first thing that I'm going to do, and this should be a habit for you at this point, X is going to be the small boxes and Y is going to be equal to the large box. So if we take a look to set up our system of equations, it says that Lisa sold 10 small boxes and 1 large box for a total of $51. So 10 small boxes plus 1 large box is equal to our $51. Then for our second one, it says that Michaela sold 14 small boxes, so 14x plus, with our and there, 10 large boxes, 10y, equals $166. So again, if you notice, your equations are already in standard form. So we are going to solve using elimination again. The easiest thing here to eliminate would be my y's, because I would only have to multiply my top equation by negative 10. So when I rewrite here, I'm going to have negative 100x. Oops, that should be minus, sorry. Minus 10y equals negative 510. And then our second equation stays the same. So I have 14x plus 10y equals 166. So when I go to solve, my y's cancel out. Negative 100 plus 14 gives me a negative 86x. Then I have negative 510 plus 166 is going to be equal to negative 344. Now I want to divide both sides by a negative 86. And I get x is equal to 4. So it's going to be $4 for a small box of oranges. And to find the large boxes, we have to take that 4 and plug it back in to either equation. So I'm just going to plug it back into the first one. So I have 10 times 4 plus y equals 51. 10 times 4 is 40, so I'm going to subtract 40 from each side. So I have y is equal to 11. And it's going to be $11 for the large boxes of oranges. So these are my two solutions here. Now, again, you guys can kind of see that it is easier to use elimination or substitution for these problems, that graphing really wouldn't be the most efficient. So why don't we scroll back up to example 2, and next to example 2, please write that you used elimination for both of these. So now you have the different types of word problems, and you can go back and reference these as to how you set them up. Make sure you answer the questions at the bottom of the page or on the next page, and we will see you tomorrow.